Okay, so yesterday I had you guys read your notes and watch my lecture video on potential energy. We're going to kind of look at each type of potential energy together. So let's again talk about the difference between kinetic energy and potential energy. Kinetic energy is a lot easier to see because there's motion. Remember, kinetic energy is energy an object possesses because it is in motion. So anytime you see any kind of movement, you know, hey, that's kinetic energy. That's easy to see. Potential energy is a little bit different. Potential energy is energy an object possesses because of its position. All right, so it's not moving. It's positioned somewhere. And where it's positioned will increase or decrease the amount of kinetic or potential energy. Okay, so we're going to look at gravitational energy. Gravitational energy is potential energy a mass possesses because of its position in a gravitational field. So Earth is a very massive object. It is creating a gravitational field. Where we place objects in that gravitational field determine how much potential energy is stored in it. And this should be very intuitive, like instinctual to you. You should be able to reason your way through this, okay? So, we have two factors that we need to pay attention to. The first one is mass, okay? Mass, the amount of matter in an object. So I have four objects up here. I have a practice indoor golf ball, so it's basically like a ping pong ball, all right? Very light, not very much mass at all, okay? I have a wiffle ball, which is not very much mass, okay? More than this. I have a volleyball, which honestly is not very much mass, okay? These two are actually, if you kind of hold them in your hand, this one feels heavier, but not by much, all right? So all three of these are light in mass, okay? Now I want you to notice they all have different sizes, they all have different volumes. That's not going to matter. All right, volume does not matter, all right? My last object here is my most massive object. It's a shot put, and it has a mass of about 4 kilograms, okay? So we're going to do a little experiment here. We're going to do a little demonstration. So I have a box of sand down here at the bottom, and we're going to use this box of sand, and we're going to see how mass affects the amount of work that's done. All right, so remember, work is when a force is applied and it moves an object a distance. So when I drop these in the tub, they're going to move sand because they're going to apply a force to the sand and the sand's going to move. They're going to make a crater. So we're going to kind of compare these craters a little bit, okay? Now, the more sand that moves, the more energy that was stored in it, because the potential energy, the gravitational potential energy, when I let go, gravity is going to cause it to move, turn it into kinetic energy, and then when that ball hits the sand, it's going to transfer that energy to the sand. The more sand that moves, the more energy that the ball had, all right? Before we do that, though, we got to talk about our second factor, height. So the higher we hold something, the more kinetic energy, the more potential energy we store in it. So the higher I hold an object, the more potential energy I store in it. All right, so I'm going to kind of come around. I'm going to have to move the camera just a little bit, so try to keep everything in the shot, so bear with me. Okay, so we're going to look at just mass. So to eliminate height as a variable, I'm going to drop all these from about the same height. So I'm going to use my desktop here as my height gauge. So I'm going to drop these two. Now, this one is slightly more massive than this one. So what we talked about, more mass, we're dropping it from the same height, more mass. This one should move more sand. Okay, so this one should have a little bit bigger of a crater than this one. So I'm going to try and drop them from the same height. Okay. So, bring the camera over here. Let's look at these. All right, so let's look at these. So this one's the golf ball. So you can see compared to the wiffle ball, it's quite a bit smaller.
we didn't move near as much sand. I would say that the wiffle ball has about twice as much mass. And if I'm correct on my estimate, we should have moved about twice as much sand. So I'm going to kind of draw a little circle around here so you guys maybe can see a little bit better at how big these craters are. Okay? You can see that the wiffle ball again moved more sand. We dropped them from the same height. Wiffle ball has more mass, so it had to have more energy stored in it. Okay? So I'm going to erase these. Okay. All right. I'm going to do the volleyball here. Volleyball's going to bounce, so I got to try and catch it. All right, so I'm going to drop it from the same height. Okay. And just for comparison, I'm going to go ahead and drop the wiffle ball again. So I'm going to go ahead and draw the circles around so when we come around here we can compare. Now again, I would say that the volleyball maybe is 3 times the mass of the wiffle ball. So there's the wiffle ball right there. And you can see how big the crater is compared to the volleyball crater. All right. Now you can see the volleyball one's much bigger, but I can tell you, it's probably hard to see on camera. The volleyball one's just a little bit deeper too, just a little bit deeper. Okay. So again, we dropped them from the same height. The one with the more mass moved more sand. It did more work. All right. Let's do our last one here. Our last one is the shot put. Now again, this is the most massive one by far. This one is probably maybe 20, 30 times the mass. Okay? So I'm going to drop it from the tabletop height. And you heard the thud. All right? So I want you to kind of see how deep the shot put kind of went in. And I'm going to kind of put a circle around the crater. Okay? So it's pretty big. And when I pull this out, you can see how deep it is. I mean, it's by far and away the deepest. It probably goes, it's hard to see on camera probably, it probably goes down about 2 inches. All right, so we dropped it from the same height as the other 3, but this one did way more work because it had way more mass, okay? So, we eliminated height as a variable by dropping all of them from the same height. All right, to show you that the more mass an object has, the more potential energy that's stored in it at the same height. All right, now we're going to do the same experiment, but we're going to change our independent variable. Okay, we're going to drop the same mass from 2 different heights. All right, so if we increase the height, it should increase the potential energy. We should move more sand. All right, so I'm going to do this again. So I'm going to kind of drop this one from here. Oh, I hit the side. Do that again. All right, so drop this from here. All right. And now I'm going to drop the same mass from a different height. I'm going to drop it from about half as high. All right, so I'm going to draw a circle kind of around our craters. All right, so this one is our high height, and you can see how big our crater is in diameter and how deep the hole went. I tried to drop this one from about half the height, so you can see it's much smaller in diameter, and it doesn't go down quite as far. It goes down about maybe not quite an inch, and this one's going down about 2 inches. We moved more sand here. We did more work. Why did we do more work? We had more energy. Why did we have more energy? We dropped it from a higher height. Okay? So, you guys can see that we changed the amount of energy stored in the object simply by changing the height. The higher we put it, the more energy it had. When we let it go, it turned into kinetic energy, hit the sand, and moved sand. It did work. Now, I've told you guys that energy cannot be created or destroyed. So let's talk about that just for a second here real quick. I want to show you something kind of neat. So when the shot put hits the sand, so I've stored energy in it. I've taken energy from my body. I'm holding this shot put here. I'm applying a force, and I'm holding this shot put here, and there's gravitational potential energy stored in this shot put. When I let go, that potential energy doesn't get created or destroyed. It just turns into kinetic energy, movement, right? Okay? When it hits the sand, it moves the sand, so more kinetic energy. But eventually everything stops moving. So where did all that energy go? Where did that energy go? It didn't just disappear, right? Well, there's two places that it goes. The first one's sound. When I drop the shot put and it hits, you hear a sound. I'm creating sound energy, which is another form of kinetic energy. But I'm going to show you also that it creates heat, friction. All right, so we're going to create two more types of energy. So I'm going to go ahead and get the temperature of the sand here. All right, so you can see it's been out in my car. The sand has. It is 54.1 degrees right now. So when I drop this, potential energy is going to turn into kinetic, which is going to turn into more kinetic energy.
Riley Mays to the office, please. Riley Mays.
And we're going to hear sound. We're going to hear a thud. So that's vibrational or sound energy. And then I'm going to take the temperature again, and you're going to see that the temperature of the sand went up. So there's the sound energy. Get this out of here. Take the temperature real quick. And you can see that the temperature went up 4 degrees Fahrenheit. All right, so energy cannot be created or destroyed. It can only change forms. Gravitational potential energy. The more massive an object is, the more energy that's stored in it at the same height. If we want to increase the amount of potential energy, we can raise the height. All right, so keep that in mind as you are doing your worksheet today. All right.